Hi, my name is Lauren Gaeta. I'm a sophomore at UNC. I am majoring in psychology with a double minor in chemistry and neuroscience. I've always wanted to be a TA. I really want a TA for Chemistry 101, preferably, or 102. It doesn't really matter, but I really like 101. I took 101 my second semester freshman year, and then I just took 102 last semester with Dr. Bleem, and I took 101 with Dr. Beaver. So I'm going to work out a problem, and yeah, so let's get into it. Okay, so the first thing I would do is gauge where their confusion is. If they don't really know what's going on, I would just start from the beginning and start explaining what all the little numbers are, because I feel like that's probably the most confusing part for them, just recognizing how to actually start the problem. I know that was always pretty hard for me, realizing how to start was the most difficult part, you know? So the first thing I would do is explain, like I said, what all the little numbers mean. So the 15 here and the 18 here are the atomic mass of the nitrogen and the oxygen. And what the atomic mass is the combination of the protons and the neutrons that are inside the nucleus of the atom. The atomic mass is basically, it's not equivalent to the mass because you have to account for the very small mass of the electrons, but it's a very easy way to be able to figure out how many protons and neutrons you have in a molecule. So the way that you figure out how many protons and neutrons you have is simply by looking at the periodic table. So I have a periodic table pulled up on my computer. You can see that for nitrogen, you can see the atomic number, which is generally above the element, but it honestly all depends on the periodic table. But in this case, we know that the atomic number is equal to the amount of protons that an atom has. So just by looking at the periodic table, we can figure out that nitrogen has 7 protons and oxygen has 8 protons. So and then oxygen has 8p. But by looking at this chemical formula, you see that oxygen has a subscript, and that subscript indicates that there are 2 oxygen atoms for every 1 molecule of nitrite. So from that, we have to recognize that this oxygen in the nitrite is going to have, since there's 2 of the atoms, it's going to have 16 protons because you have to account for both of the oxygens. So that's going to be multiplied by 2, which is 16 protons. So then you also have to double the atomic mass because there's 2. So that's going to be 36 is the AMU. But we know that there's 16 protons. So in order to figure out the neutrons, since the AMU is protons plus neutrons, you can just subtract the amount of protons. So minus 16 is 20. Nope. So then we have to look at the nitrogen, and we have to recognize that there is going to be 15 minus 7p is 8 neutrons. And then we add them together to get 28. And then we can also add the protons together to get the amount of protons in the molecule. And 16 plus is 23. So now all that's left to do is figure out the amount of electrons. And so now we have to look at this negative sign right here. So we know that this molecule is not neutral, because if it was neutral, it wouldn't have either a plus or a minus. So we have to realize that in a neutral molecule, protons and electrons are going to be equal, because protons are the positive molecules and then electrons are negative. And so in a neutral molecule, they're going to balance each other out to have no charge. But in this, we have to realize that there's going to be 1 extra electron because it has a -1 charge. So we just take the amount of protons, add 1, and you get 24 electrons. So in this molecule, we're going to have 28 neutrons, 23 protons, and 24 electrons.